So here's the second part of our discussion for the day. And this is pH. So pH is something that you're probably a little bit familiar with. We talked about this in class, and generally there's an understanding that you can evaluate a solution based on its pH and say, well, if it's acidic, or if it's basic, or if it's neutral. A neutral solution has a pH of 7. A basic solution has a pH greater than 7, and acidic solutions have a pH below 7. Now, what does that mean? Well, what that ultimately means is it's a measure of the hydrogen ion concentration or proton concentration. Now, this is the sort of problem that you should kind of get a little bit accustomed to working with. Find the pH of a sample of lemon juice, which has a hydrogen ion concentration of 3.8 times 10 to the negative fourth. Now, arguably, I can change this question. Find the pH of a sample which has a hydrogen ion concentration of 3.8 times 10 to the negative fourth. Do we care that it's lemon juice? Not really. What we do care about is writing this up. Negative log and then 3.8 times 10 to the negative fourth. Now, you'll find that in your calculator, and you'll find the log function on your calculator and basically plug all that in. And the result of this is going to be your constant or your pH. And I find when I plug that in, I get an answer of 3.42. Now, if you get a negative value, chances are that just means you forgot to put the negative in front of your log function. So keep in mind, or keep that in mind. This is what you're going to plug in, and this is your answer. Now, what does this tell me? This tells me that I'm working with a acidic solution because the pH of my solution is below 7.